This video demonstrates our system to support the creation of ephemeral user interfaces. To illustrate how a system seamlessly integrates with external systems, this example uses a program that controls Microsoft PowerPoint, as is visible in the upper right screen. To create a control, the user presses the action button and then selects which group of functions to explore. In this case, they select PowerPoint and then they select the next slide function. The system then presents relevant input options based on that function selection. The user selects button and then drags an area to define that button. They then press the action button to confirm their sizing. The user can now use this control to navigate to the next slide, as is visible in the upper right hand screen. The process can then be repeated for the previous slide function. Again, the user selects the group, the function, and the input type before they create another button to go to the previous slide. Once controls are created, the user can move or delete them by holding the action button, at which point the controls can then just be dragged around. To delete a control, that control is just simply dragged off the table into the red region. To illustrate functions that require parameters, the user can repeat the process, but this time choose the Go to Slide function. They then select the slider to navigate the slideshow. To ensure a persistent value, the user can also use physical objects to ensure a value is set. In this case, the user uses a simple unit block to assign a value. In addition to linear sliders, the system also supports curved sliders, as well as partial or complete radial dials. To create arbitrary input devices, the process is exactly the same. The user selects the function to control and then selects an input requiring an object. In this case, we use the orientation of an object. The user places the desired object on the table and then presses the action button. They are then prompted by the system to rotate the object to the initial orientation before again pressing the button. They then rotate the object to the ending orientation and then press the button again. The system then interpolates the value of the orientation of that object, given its current rotation. This same approach can also be used for 3D printed controls. For example, once printed, this lever can immediately be used as a functional one without requiring any additional electronics. For more information regarding our system, please consult the paper.